everyone. Welcome to my YouTube channel. Now I am going to explain about the introduction to the NP-hard problems. So what actually the NP-hard problems are? These are actually the class of computationally complex problems that are believed to be intraceable, meaning they cannot be solved efficiently by the computers, even with the most powerful hardware and algorithms available today. These problems pose to be significant challenges for in the field of computer scientists and researchers. So what actually the definition of it is? So NP-hard problems are the subset of the NP. What actually the NP is? Non-deterministic polynomial class of problems. So which are the decision problems that can be verified quickly by the computer. NP-hard problems are at least as difficult as the hardest problems in the NP, and they are considered some of the most challenging problems in the computer science field. Examples of these NP-hard problems are such as traveling salesman problem, graph coloring problem, knapsack problem, and subset sum problem. So what actually the traveling salesman problem is? Determining the shortest route to visit a set of locations and return to the starting point. And coming to knapsack problem, selecting the optimal set of items to include in a limited capacity container. And graph coloring problem involves assigning colors to the vertices of the graph such that no adjacent vertices share the same color. Subset sum problem is determining if a subset of a given set of numbers can sum up to the target value. And traveling salesman problem, going into the deeper, defining the problem is a given a list of cities and the distances between them. Find the shortest route that visits each city exactly once and returns to its starting point. And complexity, it is around the traveling salesman problem in NP-hard problem. The time required to solve it grows exponentially with the number of cities and making it intraceable for large instances. And applications and importance are of this TSP problem is there are many real world applications such as logistics, transportation planning, and computer chip design, making it a crucial problem to study and understanding it. Coming to knapsack problem description is, for example, take a problem given a set of items, each with a weight and a value, determining the subset of items to include in a limited capacity knapsack to maximize the total value. What complexity around it takes and what are the applications it involves comes under the picture is knapsack problem is the NP-hard problem with various applications such as resource allocation, investment planning, and cargo loading. And approaches about it involve solving this problem efficiently is a significant challenge, and researchers have developed various approximation algorithms and heuristics to tackle this problem. And graph coloring problem, to get into the deeper, graph representation is nothing but the graph coloring problem involves assigning the colors to the vertices of the graph such that no adjacent vertices share the same color. Coloring constraint means the goal is to use the minimum number of colors while ensuring that the color is valid, making this NP hard problem. Applications of it involves scheduling, resource allocation, and even the design of the computer processor registers. Coming to the subset sum problem, given there will be the set of numbers and a target sum. Determine if there is a subset of numbers that add up to the target. Computational complexity of this subset sum problem is around a class of problems that are at least as difficult as the hardest problems in the NP. And coming to the applications of it and challenges of it is, the problem has applications in areas like cryptography, finance, and resource allocation, but it remains significant challenge for the computer scientist. So practical implementation and challenges of the above NP-hard problems are the computational complexity involves are inherently difficult to solve, and time required to find optimal solutions grows exponentially with the problem size. And approximation algorithms, such as researchers have developed approximation algorithms and heuristics to find the reasonably good solutions to NP-hard problems in reasonable amount of time. Coming to real world applications, despite their computational complexity, these problems have many important real world applications, making them very important to study for everyone in their respective field. Coming to future developments using this NP-hard problems, this is very advantage to the field of quantum computing and other emerging technologies that may provide new approaches to solve any kind of hard problems, that is NP problems, more efficiently inside the future. And that's all about my presentation, friends. Thank you for coming to my YouTube channel.